history was made in July 1944 when an RAF Mosquito, one of the few Allied aircraft easily able to penetrate German airspace, was shot down by a Messerschmitt 262 flown by Lieutenant Alfred Schreiber, to whom fell the distinction of achieving the first ever jet fighter victory. If the Me 262 represented the cutting edge of fighter technology in 1944, it was the consequence of early German interest in the use of jet propulsion for military aircraft. Indeed, in the Heinkel 178, which took to the air on August 27, 1939, Germany had flown the world's first jet aircraft. Power was provided by a jet engine offering a maximum of just over 1,000 pounds in thrust. In itself, the 178 at this stage represented nothing more than a technical novelty, having no military use. For Heinkel, it had, however, demonstrated the possibility of developing a jet-powered machine that could be employed for more militant purposes. Indeed, he had already initiated studies in 1939 for a twin-engine jet-powered fighter using two new and more powerful engines. The resultant HE-280 was, at the time of its first flight on April 2, 1941, undoubtedly the most advanced aircraft of its type in the world. Powered by two jet engines, each delivering nearly 1,300 pounds of thrust, the HE-280V1 achieved a maximum speed in tests of 485 miles an hour. The fitting of an improved turbojet was expected to raise this to 570 miles per hour. By the spring of 1942, the testing of a succession of prototypes had, in Heinkel's view, proven the concept of the 280. However, its fate was to be sealed by its engine. Heinkel's own design never produced the planned thrust, and switching to the Junkers U-mode turbojet meant employing the same engine as the Me 262. The latter, which was now flying, was deemed by the Luftwaffe to have greater potential, and on March 27, 1943, Heinkel was instructed to abandon the 280. Although the political leadership of Germany has been castigated for its failure to see the potential of jet aircraft and their positive impact on Luftwaffe's fortunes in the air, it must be remembered that in the first 2 years of the conflict, it was held that the war would be a short one. Consequently, Ernst Udet, seen here on the left, who oversaw Luftwaffe projects, and Hans Jescheneck, the chief of the Luftwaffe General Staff, were lukewarm towards these projects. In consequence, their potential was unrecognized until it was too late, and Germany's lead time lost forever. Even as Messerschmitt explored the turbojet, it was also carrying out development on a more radical approach to aircraft propulsion, by mating a Walter rocket engine to an airframe designed by Dr. Walter Lippisch of the German Gliding Research Institute. Messerschmitt flew the prototype of the Me 163A in the spring of 1941. As flown, it represented an evolutionary stage between the original glider airframe and the production Me 163B. Flying trials continued at the experimental station at Peenemünde, with the 163A soon demonstrating a remarkable performance, including a phenomenal climb rate and a top speed of 550 miles an hour. On one occasion, it was towed to 13,000 feet, cast off, and lighting the engine achieved a speed of 623 miles an hour. Once the aircraft had burnt off its store of fuel, it resorted to its original state of glider. This was to be a feature of the production variant, and it shared the prototype's very hazardous landing speed. The redesign of the A variant for service use saw the emergence of the production Model B. However, the heart of the design remained the problematic Walter rocket engine. Developing a maximum thrust of some 3,750 pounds, its most dangerous aspect lay in the nature of its propellant. The rocket fuel was a mixture of 80% hydrogen peroxide with oxyquinoline or phosphate, more commonly known as T-Stoff, and an aqueous solution of calcium permanganate referred to as Z-Stoff. This highly unstable combination could cause explosions under certain circumstances. Furthermore, the pilot and ground crews wore special clothing to protect themselves against the highly corrosive nature of the fluid, which could dissolve human flesh. When tested on the ground, the engine was often cooled by water. Although an Me-163B test unit started trials of the type in 1943, it was not until May 1944 that production aircraft were delivered to the Luftwaffe. Manufacture had been dispersed all over Germany, with final assembly of the 163B taking place at a secret site deep in the Black Forest and dispatched by rail. However, production of the type was problematic. It was only in July 1944 that the first 163 unit became operational. JG400, based at Brandis, carried its distinctive unit marking of a rocket-powered flea on its nose. First seeing action on July the 28th, it was not until the 24th of August that Feldwebel Schubert, seen here, was able to claim the first kill with the type. The serviceability of the 163B was never very high, and as early as July difficulties had started to be experienced in the supply of fuel from its only refinery sources at Ludwigshafen and Leverkusen. Not only were these to become the focus of bombing raids by US bombers, but both T-Stoff and Z-Stoff were used to power the launch module of the V-1 flying bomb that was just about to come into service. Stockpiling of fuel for this purpose was deemed to be a higher priority than supplying JG400, so just 8 163s were available on the 24th of August when a force of 185 B-17s were approaching the synthetic oil refinery at Mersburg. The 163s were scrambled. Having climbed rapidly to height and to the rear of the formation, the 163s closed on the fortresses and opened fire with their 30mm cannon. The rapid speed of approach made only a very short firing pass possible. Nevertheless, Schubert was able to down 2 B-17s. Once the fuel was exhausted, the 163 made a very fast return flight to the base by gliding. The approach and landing on the airfield was made at very high speed. The small skid extending from the bottom of the fuselage did not provide a satisfactory method of landing, and many pilots were injured and killed when they came to grief at this stage of their flight. The proposed improved Me-263 was provided with a proper undercarriage, but did not see operational service before war's end. Because of the danger from other returning 163, it was vital for each one that had already been landed to be recovered very quickly. A specially designed motorized trolley was provided for this purpose. It was provided with a hydraulic lift to raise the 163 and carry it back to its hard stand. The aircraft was then raised up to enable ground crew to replace the wheeled takeoff dolly and so ready the Comet, as the type was now officially named, for its next sortie. Although much was expected of the 163, especially after the showing of the 24th of August, the hopes for the Comet were to remain unfulfilled. Indeed, the 4 B-17s shot down on that date marked the type's only aerial victories. Following the US bombing raid on the T and Z-Stoff refineries in September, the only fuel produced thereafter was diverted to service the V-1 programs, and the 163s of JG400 were left to stand forlorn and unemployed on the hard stand at Brandis, deprived of the fuel that could have enabled them to fight. However, the 163 was the most radical aircraft to see service during the Second World War. Acclaimed by many in Germany and beyond as the most formidable warplane of the Second World War, the Me-262 was to be the great white hope of the Luftwaffe that was never to be fulfilled. Although the first 262 airframe took to the air powered by a piston engine in 1941, it was only in March of the following year that the modified first prototype, fitted with prop and BMW jet engines, flew. With the rollout of the third prototype, the V3, came the first 262 to be fitted with more powerful alternative Junkers Umo jet engines. Due to the need to employ a hard runway, the 262 was transferred to Leipheim for testing, and it was there on the 18th of July 1942 that the first 262 to take to the air powered by jet engines alone made its first flight. Framed by the wing of a Gigant glider, the V-3 moved out on the runway to begin its takeoff run. At the controls was Messerschmitt's veteran test pilot Fritz Wendel. Uncertain as to whether the tail could raise itself off the runway, Wendel gently tapped the brakes, forcing the rear of the fuselage to rise. Within seconds, the 262 was airborne. On landing, the aircraft spewed out a lot of smoke, which appeared more dramatic than in reality it was. Although a number of small problems were discovered, the 262 was held to be generally satisfactory. Over the next few months, the wing was modified to give the 262 its characteristic constant sweepback. Prompted by the enthusiastic reports of one of his pilots, Adolf Galland flew the fourth prototype himself in March 1943. His reaction was ecstatic, like I was being pushed by an angel. In consequence, he recommended that all other fighter projects be cancelled and production concentrated on the FW-190 and the Me-262 alone. Galland's wishes in this matter could not be accommodated so easily. In November, following a demonstration, Hitler ordered that not only should the aircraft be given the highest priority, but that it should be built not as a fighter but as a bomber. Goering had assured him it could be equipped to carry bombs. He also demanded it be available to contest the expected Allied landings in Europe. Messerschmitt was unable, however, to surmount the technical difficulties with both airframe and engine in order to get the 262 in production either as a fighter or as a bomber in any quantity by June 1944. The latter began to leave the production lines in July and entered service with KG-51, thereafter named Commando Schenk, and first saw action over northwestern France in August 1944. The bomber variant was named Stormbird to distinguish it from the fighter version, which was christened the Swallow. Two 551-pound or a single 1,102-pound bomb could be carried on under fuselage racks, whilst it retained the nose armament of four 30mm cannon. Notwithstanding Hitler's own insistence and the politicking from other persons also demanding that the type be produced as a Blitz bomber, the principal concern of many in the Luftwaffe was to see the 262 in service as a fighter. First deliveries of the Swallow actually preceded those of the bomber variant, with the 262 test detachment, under its first commander Hauptmann Thierfelder, making its first operational sorties in April 1944. With his death, leadership of the detachment was passed by Galland to Major Walter Nowotny, the ace of the Eastern Front, after whom the unit now became named. It was a 262 from Commando Nowotny that was employed in the making of this training film for new pilots converting to the type. This was very necessary because the 262 required a different approach than when handling a piston engine type, and the technical superiority of the jet did not automatically confer itself on the pilot. Although a high-speed aircraft, it accelerated slowly due to the still temperamental nature of the UMO engines. Throttles had to be opened slowly, otherwise the pilot could find the engine suffering a compressor stall, burnt-out turbines, or total failure. Once in the air, he could not use the plane as just a faster 109 or 190. Dogfighting was not possible in the 262 by virtue of its large turning radius, which meant that a Mustang, Thunderbolt, Spitfire or Tempest could turn inside it. Diving attacks from the rear to gain speed would allow 262 formations to easily penetrate an enemy fighter screen and allow them to hit the big US bombers employing their heavy nose armament. Having already referred in passing to the problems being experienced by Junkers and Messerschmitt with the UMO engines, it is necessary to go into the background in more detail to gain a clearer understanding of the problems besetting both companies in attempting to get the Me-262 into service in large numbers. Although the importance of the Me-262 to the Luftwaffe's future had been recognised as early as June 2, 1943, with the go-ahead to release the type for production as a fighter, This decision had taken no real account of the severe technical problems still facing the manufacturers of the aircraft and its engines. Some measure of these can be gained by noting that 6 months after this decision had been taken, only a further 23 Me-262 airframes had been manufactured by Messerschmitt, and even these were not flying due to a lack of engines. Junkers was having very great problems overcoming just the technical difficulties with the engines without even beginning to grapple with those entailed in gearing up to produce them in the quantities needed to power not just the Me-262 but also the Arado 234 bomber. At the heart of Junkers' problems with its jet engine lay those generated by the declining war situation facing Germany, over which it, as a company, had no control and could not surmount. The UMO 004 jet engine was, at this time, the most advanced of its type in the world. As a state-of-the-art power plant, it required precision manufacturing of parts made from specialized and valuable metals, able to withstand the greatest stresses and temperatures associated with jet engines. These included nickel and chromium, which were no longer obtainable by the Reich in 1944. In their place, Junkers had to utilize inferior materials in the manufacture of vital parts, or use what little store of strategic metals they possessed in a far more frugal fashion. For example, under normal circumstances, the combustion chamber would have been constructed of aluminium, but with the shortage of this vital metal, Junkers had to manufacture the same part from steel and impart a thin sprayed layer of aluminium to the inside surface to help it withstand the heat. In consequence, the 004 engine possessed a service life of barely 10 hours before it seized up. Problems with the compression flow resulted in compressor stalls. The fuel supply to the engines was also extremely difficult to regulate. If fuel was released into the turbine too quickly by the pilot, it would induce a flameout. These numerous problems thus lay at the heart of the inability of the Luftwaffe to deploy the Me-262 in the desired numbers. Hitler's insistence that the aircraft be used as a bomber and not as a fighter is therefore seen in its proper perspective as being incidental to this central problem and not a cause of it. While German ingenuity had produced an extremely advanced aircraft, her war industry was unable to overcome the debilitating problems associated with the manufacture of its power plant that was the prerequisite to its deployment in the reliable numbers necessary to ensure its success in the air war over Germany. As the war situation deteriorated still further and the strength of Allied bombing increased, as pressure built from Hitler to get his Blitz bomber into service, it was decided in June 1944 to forgo any further major redesign work on the UMO engine, freeze the design with all of its faults and begin full production. It was this decision that saw the beginning of deliveries to the Luftwaffe, with 28 Me-262As accepted in June, 59 in July, just 20 in August, 91 in September and 117 in October. In total, the Luftwaffe had received 315 by the beginning of November 1944. However, it was still the case that almost all the 262s being produced were earmarked for fighter bomber duties. Hitler could not be moved on the matter. Within a month of his appointment, the new Luftwaffe Chief of Staff was pressing Hitler to release the 262 for service solely as a fighter. The only concession the Führer made was to allow every 20th aircraft to be produced as a fighter. This was unacceptable to General Kripe, and it was on this issue he tendered his resignation in September. It was only in November that Hitler finally relented and gave the go-ahead for the 262 to be produced as a fighter. Although obstinate to the last, he insisted that each aircraft must be able to carry a 551-pound bomb in an emergency. So bad was the war situation by this time that the Luftwaffe and Messerschmitt ignored his command on the matter. While records show that over 600 262s had been received by the Luftwaffe by January, many never reached their Luftwaffe operators as they were destroyed on the trains carrying them by Allied fighter bombers. Even for those 262s in service, extreme care was needed to protect and camouflage them on the ground from marauding Allied Yabos for whom the German jets became primary targets. The inbuilt armament of the 262 was the most formidable carried by any German fighter in the war. This comprised 4 30mm cannon mounted in the nose. In addition, 24 unguided R4M rockets could be carried on underwing racks, adding a weight of fire of 53 pounds to that of the cannon. In an effort to equip the 262 with heavier firepower, a number were converted to test the mounting of 50mm cannon for anti-bomber work. 2 types of weapon of this caliber were employed in tests beginning in January 1945. This demonstrated that carriage and firing of the weapon produced no great problems with the handling of the jet in the air. Based at Akma near to the Belgian border, Commando Novotny was too close to Allied air bases to work up the new fighter free from interception. Allied fighters soon discovered that the 262 was at its most vulnerable when landing and taking off, and bounced them. So protection flights of Me-109s and FW-190s had to be provided. Galland was visiting Akma to talk with Novotny when the young commander and fighter ace was killed. On the 8th of December 1944, with Galland still at the base, he took off in his 262 to attack US bombers. With his aircraft having been hit, Novotny tried to regain the base, but he was in an air battle with Mustangs with only one engine working. His 262 plunged out of the skies and dived vertically down to its destruction. As a darling of the propaganda department, he was given a state funeral, dead at the age of 24 with a total score of 258 victories, making him the 5th highest scoring fighter pilot of all time. His command was dissolved to become the new 262 unit JG7. Me-262s continued to operate through to war's end, and March 1945 was to see their most successful employment. On the 18th, 37 262s engaged 1,221 bombers, escorted by 632 fighters, attacking Berlin. 12 bombers and 2 fighters were shot down by the jets, which used the R4M rocket for the first time. On the last day of March, 262 shot down 14 Allied bombers and 2 fighters for no loss to themselves. In southern Germany, JG-44, the special 262 unit commanded by Adolf Galland, now sacked as Inspector General of Fighters, also engaged in combat, flying out of Munich Rhine. Although a grand total of 1,200 262s had been accepted by the Luftwaffe by early April, less than 200 had actually been allocated to units. In this extremely rare piece of film, an Me-262A 1A/U3 Recce variant is seen just after its return to base from a photographic sortie. This particular aircraft belongs to Nahauffklärungsgruppe 6, which was originally designated Einsatz Kommando Braunegg and was serving in northern Italy in March 1945. A mere handful of this variant was built, the maximum number in service at any one time being 7, recorded on March the 31st, 1945. A window is incorporated in the pilot's floor so he could see what he was photographing, the nose cannon having been removed to fit a variety of camera options. Some pilots did opt to keep a single 30mm cannon alongside their cameras. Arado's AR-234 was the world's first operational jet bomber. Its performance in the reconnaissance role in late 1944 and early 45 was to prove how right its builders were to christen their creation the Lightning, as it swept through Allied airspace with virtual impunity. Indeed, it was to satisfy a 1940 specification for a fast recce type that the 234 was designed. The prototype emerged in 1943 with high-mounted wings and a fuselage cross-section so slim as to preclude the fitting of a conventional undercarriage. The variant seen here being the later type. In the absence of a conventional retractable undercarriage, Arado had designed a 3-wheeled trolley that would attach to the underside of the aircraft. This led to the ungainly and militarily unpractical process of raising the whole airframe on jacks and then lowering it bodily onto the trolley. In the early days of testing, the 234 took off with the trolley attached, as can be seen here. For the pilot bringing the 234 back to land on the trolley, the whole experience was decidedly unpleasant and very dangerous. The sink rate of the aircraft and the fairly high spring in the suspension of the trolley led to a very bumpy ride down the runway, with very little control being exercised through the brakes. By the end of the runway, the pilot has lost control and the aircraft pulls off onto the side and swerves onto the grass. The test aircraft was then flown once again, employing the trolley for takeoff. When takeoff speed was achieved, the pilot jettisoned his undercarriage. This in turn released a parachute to break the trolley's forward momentum and to stop it bouncing up and possibly hitting the aircraft in the underside. Trolley takeoffs were also made employing two Valter rocket pods for extra thrust. These gave an additional burst of power for some 30 seconds and allowed the 234 to make a much more rapid climb out, so avoiding any chance of collision on its underside by the trolley. Once in the air, the 234 demonstrates the turn of speed that made it so difficult for Allied fighters to intercept. While few could doubt the sparkling performance of the 234, its use of an under-fuselage skid and two smaller ones mounted under each engine when landing severely restricted its operational usage. It was thus accepted that the Arado 234 would need to be redesigned to enable the fuselage to accommodate a more conventional retractable undercarriage. The V8 model of the 234A was equipped with 4 UMO engines to serve as a testbed for the proposed 4-engine C model. This would have the same airframe as the B variant, but would mount 4 UMO engines. The 8th prototype of the AR234 was also the first produced to the B specification. This was constructed with a slightly wider body that allowed a strong but narrow track nosewheel undercarriage to be fitted. Taking to the air for the first time on March the 10th, 1944, the 234B became the first production model, with deliveries to Sonderkommando Gotz taking place in September 1944. Aircraft from this unit were employed to fly over southern England. In the meantime, 2 of the earlier skid-equipped A models had already shown their worth by reconnoitring the Normandy bridgehead without interception. The bomber variant of the 234 first saw service with KG-76 in the Ardennes offensive and undertook abortive raids against the Remagen Bridge in early 1945. The bulk of the 274 built were B models. The Me-262 and the AR-234, in whatever variant, were 2 of the most remarkable aircraft to see service in the Second World War. When the Allies plundered the design offices of Germany's major aircraft companies, they found designs for a huge number of jet aircraft, many of whose features would find their way into the first generation of post-war jets. The relative impotence of the Luftwaffe's bomber force in the West to carry out any sort of effective bombing campaign against the British Isles from 1942 onwards made the attraction of a fast unmanned flying bomb irresistible to Adolf Hitler. In the Fiesler Fi-103 he had at last the Vergeltungswaffe, or revenge weapon, with which he could hit back and retaliate for the increasingly devastating raids conducted by RAF Bomber Command on German cities. Powered by an Argus Pulse jet engine producing just 740 pounds of thrust, the newly christened V1 could carry a warhead of 1,870 pounds on a fuel load that would give it half an hour's flight time at about 400 miles an hour at an altitude of up to 4,000 feet. After trials at Peenemünde on the Baltic, the V1 was released for service in 1943. The missile was launched from a long ascending ramp using a device powered by the same fuels used by the Me-163. Scheduled to begin operations in December 1943, it was only on the 13th of June 1944, and a week after the landings in Normandy, that the first V-1 launched from the Pas de Calais began a German rocket bombardment of London that was to last until the 5th of September. The first missile to reach the environs of London crashed on empty ground. In the face of a mounting campaign of robot bombardment, British countermeasures focused initially on the provision of massed anti-aircraft batteries along the approach routes of the planes. Detachments of heavy 3.7-inch anti-aircraft guns, supported by the lighter 40mm Bofors, expended large quantities of ammunition in their bid to shoot down the V-1s. Although sometimes successful, the number of hits increased only when radar was able to provide fire control for the guns. A measure of the intensity of V-1 operations was that, in their second period of launchings between the 15th of June and the end of that month, no fewer than 2,442 were launched at London. Crashes and guns accounted for about one-third of these over the Channel. Another third either crashed or were brought down over southern England, while the remaining third, approximating to about 800 missiles, impacted on targets in and around London. For the inhabitants of southern England and London, the arrival of a V-1 was signalled by the growing growl of its Argus pulse engine, which prompted the natives to nickname the type the Buzz Bomb. The psychological effect of the weapon was enhanced by its totally indiscriminate nature. It fell to earth only when its fuel ran out, this being signalled by its sudden silence before it impacted with the ground in a great explosion. Although the populace of London displayed the same stoicism as in the Blitz of 1940-41, the V-1 still accounted for 2,441 deaths and 7,107 cases of serious injury during the campaign, as a result of an average of 53 missiles being launched each day against Britain's capital city. Even so, British intelligence was able to shift the targeting of the V-1s by feeding false information of damage to the Germans to help ease the bombardment. Aerial countermeasures provided by the RAF against the V-1 included the first use of the Gloucester Meteor F-1 jet fighter. Piston engine types employed to shoot down the robot aircraft included the superlative Hawker Tempest and Spitfire Mark 14s, with the latter responsible for shooting down over 300 of the buzz bombs. Restricted as they were to launch sites in the Pas-de-Calais by virtue of the limited range of the V-1s, the initial fixed ramps had been targeted and destroyed by Allied bombing even before D-Day. With the capture of that region by British and Canadian ground forces in September, the V-1 bombardment ended. However, the suffering of London was not yet over, as the Germans began use of a new weapon. Although the V-2 rocket, more properly known by its A4 designation, was an Army rather than a Luftwaffe project, it has a fitting place in this account of Germany's most advanced airborne projects during the Second World War. Rightly regarded as the instrument which gave birth to the modern rocket age, and the product of Nazi Germany's largest and most expensive military program, it truly represented the cutting edge of that nation's technology during the conflict. However, Albert Speer, the Third Reich's former Minister for Armaments Production, when reflecting on past events in the quiet of his cell in Spandau prison while serving a 20-year sentence for war crimes, candidly admitted that, notwithstanding the technical brilliance of the A4 program, it was, from a military and industrial point of view, a profound waste of Germany's resources. Having its origins in pre-war research, the program to develop a long-range rocket was to occupy thousands of scientists and army personnel on the secret testing ground at Peenemünde on the Baltic for many years. Progress in the light of the very advanced technical hurdles to be surmounted in the creation of such a new weapon was slow, and early prototypes of the A4 often came to grief. It was on October 3rd, 1942 that the first successful A4 launch took place from the Test Stand 7 at Peenemünde. The rocket streaked skyward, breaking the sound barrier as it rose, and hurtled out seaward to land 120 miles downrange. Further development and testing continued, with the type becoming increasingly reliable, and even a once skeptical Hitler was coming to view the long-range missile as an operational possibility. In July 1943, with the A4 now viewed as one of the new revenge weapons with which he could strike at England, Hitler committed German industry to a massive program in which he demanded no fewer than 900 of the rockets to be produced monthly. Drawing as it did on valuable metals, electronics, higher engineering skills and masses of labour, the project naturally made severe inroads on other aspects of Germany's war economy at a time when it was hard to put to service the demands for more conventional weapons. The scale of the project drew it to the attention of the SS, and it was under their auspices that a huge underground factory, constructed by and employing slave labour, was built in the mountains at Nordhausen in Germany to mass produce the V2. Because of the scale of the program, many of the more sophisticated components of the rocket, such as the gyros, control vanes, fuel tanks, and elements of the guidance system, were subcontracted out to specialized manufacturers possessing the necessary skills, and then shipped to the point of assembly for final construction. Integration of the many elements that made up the rocket required a continual process of testing and monitoring to ensure that the completed rocket left the factory equipped, ready for launching. First employment of the V2 came on the afternoon of the 8th of September 1944, when one crashed on Chiswick, one of the suburbs in the west of London. The victims of the 1-ton warhead carried by the rocket included 3 dead and 17 injured. Launch point for the missile was The Hague in Holland. Being a mobile system, it was very difficult to target, and once launched, the rocket was invulnerable to countermeasures. Over the next 7 months, the Germans were to launch 1,054 rockets on London, killing 2,700 people in the process. No Allied military resources were diverted to deal with the weapon, and contrary to Hitler's expectations, had no appreciable impact on the course of the war. What now follows is a detailed presentation of how the rocket was deployed and fired by the launch team. We begin the cycle with a V2 in the final stages of assembly. A technician working on the rear or bottom of the missile uses test equipment to check over the status of the rocket motor prior to the bottom fin section of the rocket body being placed over the power unit. Testing at this stage of the process is vital, as once the body shell is placed over the rocket, it will not be possible for the launch team in the field to get at the internals should there be a problem. Already in the field are elements of the launch team. A heavy-duty Fawn 4x2 Zugmaschinen tows the all-important liquid oxygen fuel container. Another vehicle tows a mobile generator. The Fawn lorry towing the LOX tanker can clearly be recognised by the wisp of oxygen venting off into the air from the rear of the large tank. This small convoy is passing through a village as it makes for the pre-arranged launch site. The V2 was a large piece of equipment and was at its most vulnerable when being moved from its place of assembly and completion to the front by rail. By the time the Germans began their launch of the V2 from The Hague, Allied forces were already in Europe and advancing into Belgium and moving on Holland itself. The whole road and rail network in northern Germany and the Low Countries, still servicing the needs of the Wehrmacht, was under constant surveillance and attack from wide-ranging Allied fighter bombers. It was for this reason that many, if not all, V2s sent to the frontline units were camouflaged to disguise them from the air. Clearly, those we are seeing here, being coloured in large sections of black and white, are test rockets, and the film has been made as an exercise for instruction purposes. That notwithstanding, what is seen here is an accurate depiction of the whole process used by all V2 launch teams in their preparation of the rocket, from its arrival at the railhead through to its actual launch, and is therefore characteristic of all launches of the V2 undertaken during the bombardment of London and later still of Antwerp. Using a mobile gantry, the rocket is manhandled by some of its ground crew from the train onto a purpose-built trailer. Of note is the lack of the warhead, which was transported separately from the main rocket body. At a site well away from the railway siding, the rocket armourers take off the seal covering the nose of the V2 and prepare to fit the actual warhead. This is found in its own sealed container section, which is raised up to the nose of the rocket body using a chain and tackle located on another mobile gantry and then offered up to the nose. Great care is taken to align the warhead module with the main body of the rocket before a firm connection is made and the warhead assembly is locked onto the body of the rocket. The warhead weighs 2,150 pounds. Elsewhere, other members of the large V2 crew raise another telescoping trestle. These were standard issue devices and were also employed by the maintenance units attached to panzer formations, where they could be used to lift off the turret of a heavy Tiger tank during field repairs. The lifting capacity was about 15 tons. With the warhead now fitted, the Vorn Zugmaschinen pulls the V2 up and underneath the newly raised field gantry. A second Vorn lorry drives up to park alongside the first. It pulls the specialised trailer which is used to carry the now assembled V2 to its launch site, and once there raise it so that it can be placed on its pre-sited launch platform. The lifting tackle on the mobile gantry is now used to move the V2 rocket from its rail transport vehicle to the specialised carrying trailer. The slow progress of moving the rocket from one trailer to the other is indicative of the delicacy used by the ground crews in moving the missile. It is important to avoid any damage. Great care is exercised by the crew in locking down the V2 into its carrying cradle. Although empty of fuel, the warhead is now fitted and everything is done to prevent the missile parting from the cradle in the event of an accident. As can be seen, the rocket is securely locked into the framework of the carrying trailer. The rocket is now taken off to the launch site. At the railway halt, another detachment of the crew responsible for the specialised task of fueling the rocket arrives to connect the pump that will enable transfer of the liquid oxygen from the sealed railway container holding the cooled fluid into the mobile container, from whence it will be pulled by lorry to the launch site of the V2. Once all the pipe connections are made, the valves are opened and the transfer of the cooled liquid oxygen begins. The low temperature of the liquid is evident from the white colour of the connecting pipes and in the vapour venting off into the air. At the chosen launch site, another Vorn Zugmaschinen pulls a trailer which carries the launching base for the V2. The crew begin the task of setting up the launcher. On each corner of the launch platform is an adjustable telescoping support. They are lowered by crank and placed onto the ground in preparation for the arrival and erection of the rocket. While this particular exercise clearly employs a hard stand, which makes the task easier, in actuality the mobility of the V2 permitted it to employ any fairly level clearing in a forest to launch the rocket. In order to stop the whole edifice from sinking into the ground or toppling over, railway sleepers or lengths of steel girder were placed onto the ground. The crew would then rest the 4 supporting jacks of the launcher on these. Such methods were used in erecting the launchers in The Hague. Prior to raising the rocket, a number of the crew place a special cradle on the nose. This will help in the final adjustment to the warhead just before the V2 is launched. The Milewagen is then winched towards the launching platform by the Vorn towing vehicle. This has parked itself behind the launch platform. Cables are run through to the Milewagen and it's pulled towards the launching pad. Having reversed the trailer so that the base of the rocket faces the launch platform, the Vorn then disconnects itself and leaves it up to the ground crew to literally pull and manhandle the trailer and V2 so that it arrives in exactly the correct position for raising. This process is then carried out employing the hydraulics on the trailer itself. This is a slow process as it's vital that the base of the 4 fins of the V2 align totally with the bottom of the launching platform. Very slowly the V2 inches up from the horizontal into a near vertical position. Very great care is exercised during this procedure. When the boom operator is certain all is well, the gantry is pulled away, leaving the V2 resting by itself and without support on its launching platform. At this stage of the process, the rocket commander gives the word by radio for the fuel lorries to make their way to the rocket for the next and most dangerous phase of the launch cycle to begin. The gantry is then manhandled away from the standing rocket by the ground crew. They also check that all is well by a quick but expert examination of the rocket and platform. Civilian surveyors attached to the launch team use their theodolites to ensure that the missile is correctly aligned to the vertical, as even a slight deviation could affect the path of the rocket through the air and thus its accuracy. Another member of the crew now arms the warhead. Although fitted earlier, this particular exercise was not carried out. Down below, the mobile generators are brought up to begin powering a number of the rocket's internal systems, such as the turbo pumps, and help in the fueling process, which is due to begin shortly. The fueling pipes are being connected. The liquid oxygen tank on the V2 has a capacity of 12,200 pounds and is mixed with 9,201 pounds of ethyl alcohol and 379 pounds of hydrogen peroxide to enable the rocket to generate the 55,000 pounds of thrust needed to propel it on its journey. Following the liquid oxygen, the last important ingredient is the sodium permanganate, which is added to the lower fuel tank at the bottom of the rocket. The next step is to assemble the igniter, which works on the principle of the Catherine wheel. Activity around the site is now much greater as the time for the launch approaches. As the final adjustments are made to the base of the missile, including checking the motion and alignment of the guidance vanes, all vehicles and other personnel make their way from the scene to take cover. The igniter is placed in the venturi and connected up. The V2 is now ready for launching. The launch is made from within an armoured variant of an 8-ton half-track.
Schüssel steht, aufschießen. Belüftung klar, Zündung klar, Vorstufe klar.
While of questionable military value, the V2 was undoubtedly a remarkable technical achievement. Perhaps the most fitting epitaph for this most potent of all of Germany's advanced aircraft and rockets were the words spoken by Walter Dornberger to Werner von Braun, the V2's designer, on the day of its first successful launch. Do you realize what we have accomplished today? Today, the spaceship was born.